today is all about one-sided limits. So we're going to use graphs and look at limits as they approach from the left side and the right side. So a left-hand limit is a limit where the negative sign is up in the exponent and it's after the x value. So it will say like as x approaches 2 and then have a negative up in the exponent. That means from the left-hand side. So if you see a graph and we're thinking something like that, it's going to ask you just to go this way, not from the right-hand side, which we did the previous day. A right-hand limit is something where you're going to see a plus here. So a right-hand limit is exactly what it sounds. You're going to just look on the right-hand side. So what we do from left hand and right hand is then we compare them. So if the left hand and the right hand limits have that same number, then the limit exists and it's whatever that number is. If the left hand and the right hand limits do not equal the same number, then we say the limit does not exist. So best way to learn is to practice. So looking down here, we're going to use that graph and fill in all these missing information. So it says limit as x approaches -2, and then it has a negative up in the exponent. So I know that's talking about the left hand limit. So as x approaches -2, I'm just going to look at the next left side. So here's -2, and we're only looking on the left side of it. So as x approaches -2, my y value is getting closer and closer to 0. So what we say is limit as x approaches -2 from the left hand side is equal to 0. Then what I would do is I would look at the next one. Now this says limit as x approaches -2 from the right hand side. So this is a plus, which means right in the exponent. So now what I'm going to do is look at it only from the right hand side. So my blue graph is my right hand side and it's getting closer and closer, my y value, to -2. So therefore the limit as x approaches -2 from the right hand side is -2. Now the next one doesn't have a plus or minus sign in your exponent, so it just means overall. So what we're going to do is we're going to compare our left hand and our right hand limit. So our left hand limit was in part 1, we got 0 there. Our right hand limit was part 2, and we got -2. So notice how those two values are not the same number. Therefore, we say the limit does not exist, since 0 does not equal -2. Now, if they were equal, then that's when the limit would exist. So let's take a look at the next one. So when it says f of -2, it means the actual value of it. So you're looking at a closed circle on -2, which is here. So my y value is -1. So that's how you do left and right hand limits, and then look at it overall. So let's try a few more then. So this one says limit as x approaches 0 from the left hand side, because negative's in your exponent. So as it approaches 0, I notice it's this blue graph, and it gets closer and closer to 2. So my limit as x approaches 0 from the left hand side is 2. The next one says limit as x approaches 0 from the right hand side. So now I'm going to look at my green graph because it's on the right hand side of 0. So as I'm getting closer and closer, I notice my limit is getting closer and closer to 1. So this would mean limit as x approaches 0 from the right hand side is 1. Now remember, when it doesn't have a plus or minus in the exponent, it means overall. So we have to compare our left hand limit and our right hand limit. Our left hand limit, we got 2. And then our right hand limit, we got 1. I know 2 does not equal 1 because they're not the same number. Therefore, this limit does not exist. So they have to be the same number in order for it to exist. The last one is just saying, okay, what's the real value when f of 0 is on your graph? So if I'm looking at f of 0, that means x equals 0. I'm looking for a closed circle on that, and that would be 1. So f of 0 equals 1. Now that's a graph given to you, but you may be asked to make your own graph. So on the next one, it says graph and find the limit. So again, this is a piecewise function. You're going to graph the first one, x plus 3, for every value less than 0. So, and I notice it would be an open circle because it's less than. So starting at 3, because it's an equation of a line, it's going to be open circle. My slope is 1, so I go down 1 over 1. Now I can't go up because all my x values have to be in the negative side. So I'm going to stay to the left of 0. So down 1 over 1 all the way out until you run out of graph paper. So that's that first line. The second line just says for if x is greater than 0 or equal to it. So because it says greater or equal to, it's a closed circle, and then all my x value or all my y values are going to be 0, so it's just going to be a horizontal line. We have to make sure we label our graph. Now we're going to look at the limit. So what you have to do is you have to look at from the left side and the right side. So left side, we're going to do limit as x approaches 0 from the left side of f of x. And now we're going to look at our graph as it approaches 0 would be this line here. So as it goes to 0, I notice it gets closer and closer to 3. Then I have to see if my right hand limit would be the same. So my right side, I'm looking over here. As I approach 0, I notice my y value gets closer and closer to 4. So these are not equal. 3 does not equal 4. Therefore, the limit does not exist. Last thing we're going to do is we're going to use those transformations and transform a graph and then find the limit. So looking at C, what I did is I copied and pasted your formula from previous units just so you can remember what every value does. So this is our original function. Number 1 says g of x equals f of x plus 2. So plus 2 is on the outside, which means it's going to be up 2. So I'm going to take every solid point I see. So these 4. And I'm going to move it up 2. So starting at negative 3, 2, it's going to go up 2 to here. Negative 2, 0 is going to go up 2 to here. 3, 1 is going to go up 2 to here. And then 4, 1 is going to go, 4, 0 is going to go up 2 to here. So this is my g of x. So now I got to find the limit as x approaches 3. So here's the x value 3. I have to see what it's doing on the right hand side and the left hand side. So as I'm coming up to 3 here, I notice my y value gets closer and closer to 3. As I'm coming up from 3 from the right hand side, it's getting closer and closer to 3 as well. So since my left and right are equal, what I say is my limit as x approaches 3 of g of x equals 3. So if you want, I want you to pause this video and then try the next one, and then I'll show you the answer. So plus 3 means left 3. So I'm going to take my function and move it left 3. So my new function would look like this. And now this time we're finding the limit as x approaches 1 from the left hand side. So remember, that's a left side limit only. When it has plus, it's right. When it has nothing, it is both. So as it approaches 1 from the left hand side would be here. As it's approaching 1, I notice that my value or y value gets closer and closer to 0. Therefore, we say the limit as x approaches 1 from the left hand side is 0. So now I want you to go over to your homework and then try those practice problems.